All right, so number 5 on the mid-segment page says if DE equal 10, then BC equal what? Now, if you remember the mid-segment theorem, a mid-segment is when you have a line that, and it's formed, or a line segment formed by, first of all, let's look at the side AB. If the midpoint of AB is D, okay, so we got that point. And then on the other side, if the midpoint of AC is E, that's what it takes to be a midsegment. And midsegments are always parallel to the base here, okay? And the midsegment is half the length of the base. If you watched, well, we went through it here in class, half length of the base. We had in 10.2, there was that video out there, or we did it in class if you were here, where it went through the proof for numbers 24 through 34 on 10.2. We talked about some of that, in that video about how the midsegment is half the length of the base, and we kind of used that in a proof last time we had class. So if DE is 10, I know that it is half the length of BC. What would BC end up being? 20, okay? So let's just do a couple of these to get the hang of them. 6. If BC is 12, what would DE be? It'd be half, okay? So DE would be half of BC because it's the midsegment. It's half the length. It would be 6. Number 7, I'll just mark that 10 out there. Number 7 says if DE is 2x and BC is x plus 12, find the length of DE. Okay, DE is half of BC. An easier way to work with that in a problem, wouldn't it be easier to say that 2 times DE is equal to BC?
Yeah, that's what
that way you wouldn't have a fraction. If you don't like fractions, that would work a little bit better to say 2 times DE is equal to BC. I could have said DE is half of BC, but that's got a fraction. We don't like fractions, right? So, let's see. If I want to solve for x and find how big DE is, I could say, okay, well, they told me DE was 2x. And they told me BC was x plus 12. So I just have a little equation to solve. On the left-hand side, 2 times 2x is 4x. And then x plus 12 over here. If I want to solve for x, I could subtract x from both sides, which would be what? 3x is 12. So x is, divide both sides by 3, it would be 4, right? So x is 4, but they wanted to know what DE is. DE was 2 times x, right? So that's going to be 2 times 4. So DE would be 8, okay? Okay, so number 11, they want to know what is x, right? So for part of this, what you're going to need to do is just kind of work from the top down. If you ignore anything past that 4 and that last 4 and that last 3, if I were like to stop looking about right here for just a minute and pretend that bottom didn't exist, I can tell this is a midsegment because 4 and 4 on either side of that point makes that the midpoint of the left side, right? And on the right-hand side, I got 3 and 3. You okay?
Yeah, sorry.
So that midpoint, that's got to be the midpoint there since those numbers match above and below. So if I've got that small line being 5, what does that make that larger line that I scribbled over? 10, okay? Now I'm ready to move down and look below that yellow line. Is that a midsegment? It's not drawn to scale. It doesn't look like one, but is it? It is, because 4 and 4 together make 8, and 3 and 3 together make 6. So that's another midsegment. It's just not drawn to scale, which is not unusual in geometry problems. You always have to look at the labeling, not the way it looks, or you get yourself into trouble, especially on the SAT. Okay, so since that's a midsegment, since I have 8 and 8 above that yellow line, 6 and 6 below the yellow line, then x is just going to be 20, right? Because 10 would be half of whatever that longer piece is, so it's 20. Okay, so 16. Y'all ready? Is B a midsegment? No. I'll color code this. I'll use blue for this one. These numbers aren't matching. So you can't find B. It's not really a midsegment. They tried to draw it where it looked like it, but it's not. If you turn your paper so that C is facing up, now I can't do that on this because, it still, it won't turn. But if you could turn your paper, I'm going to use a different color. Let's look at C. Is C going to be a midsegment? No, because you still got that 31 and 32 that's messing it up. It's not dividing that side exactly in half, is it? A is the only one you can find. Honestly, I think it might be A in all of them. I can't remember from the key, but it seemed like when I was working with the ninth graders today, the other two ended up being A. A works. Let me write A in purple. Oops, that's not what I wanted. Did not want fill color. No fill. I wanted that. Okay. So if you look at A here, A divides this side here where I'm drawing the big dot in half because there's 21 and 21. And if you look where it hits the other side, you got 16 and 16. So it's a midsegment. So you can find A. A is going to be half of this base down here that I'm darkening right now. So if I add 31 and 32 together, I get, 63? So if I split that in half, yeah, it's going to be a decimal value.
31.5.
What is it? 31, thank you, 31 point, well, yeah, that kind of makes sense, doesn't it? If you average those numbers. So A is 31.5. Good. You okay?
Yes.
Okay. Just scream in pain if you need to. Okay. And you're supposed to tell if there is postulate that would prove each pair of triangles similar. Now, normally what I would tell you to do here is to divide the two triangles out like this, because you got to be careful. This the bigger triangle isn't it like it's twice this little one, isn't it? Like if I call this side A, wouldn't this side be 2A? Right? Because they marked it. Those pair of double markings mean that those pieces are equal. That's actually a midsegment, isn't it?
Yeah.
In that little line of midsegment. So if you know it's a midsegment, you know there's a couple ways to approach this problem. Let me do it the similar triangle way, then we'll do it the midsegment way, because you could get two different answers here. You really got a lot of information here if you know about midsegments. If I called this little side of the smaller triangle B, then wouldn't the big triangle be 2B?
Or not to be.
That is the question. Okay. Now, isn't this angle matching this angle right here?
Yeah.
Okay. Are my sides proportional? Yeah. This side's being multiplied by 2, that side's being multiplied by 2, right? So my sides are proportional, so I'm going to mark with different color markings because I don't want to use those markings anymore. So ignore the purple markings at this point. This green mark, that side's proportional to this side, and this side with the green marks is proportional to this side. They're both in a ratio of 1 to 2, right? So they're proportional. I can see that because of the labeling. And this angle is congruent to this angle. So you could say that this is similar by side angle side. If you remember from your notes, you had different reasons that triangles were similar. Angle made it similar. You couldn't say something was congruent by angle, but you can say it's similar. We had side angle side, and I'm guessing, I'm trying to remember what was on those palm tree notes. Angle side was probably on there. You have a lot of the same ones, but you have this additional one, angle, that you don't have with congruent triangles. Because all my angles could match up, and I've just blown the thing up to be a whole lot bigger. Okay, if I'm thinking about midsegments here, though, I might have got a different answer. I might have said, I knew that information. If these are the middle here, I do know that those sides are still in the same proportions that I wrote over here. But just think about the midsegment theorem. Let me use a different color here. Doesn't the midsegment theorem tell me that this side right here is twice this side? So if I called this little side C here, doesn't the midsegment theorem tell me that's going to be 2 times C? Okay, so by the midsegment theorem, I could actually say these two triangles were similar by side. all three sides are in the proportion 1 to 2, aren't they? Normally these aren't that hard. This is kind of a hard one to start off with, I think, just because we know so much information, we might confuse ourselves, I think. I don't know what y'all think, but anyway. Okay, let's do a couple of these. Let's see how much. I'm going to go real quick. Number 2. What kind of triangles do I have here? Isosceles, right? Since they're isosceles triangles, if this is 40 degrees, I know that these two angles down here would be 180 minus 40 is 140, right? Yeah, 140. And I got to divide that in 2. And wouldn't that be 70? And wouldn't that be 70? Since they're isosceles. Wouldn't the same thing be true over on the other triangle since it's isosceles and it's got a 40-degree angle? So if I wanted to, I could say that these two were similar by angle.
Could you do side angle?
You could do side angle side also. See how sometimes there's more than one way to do it, okay? So side angle side also.
I got none.
Yeah, I think 3 is going to be none. Why is 3 none? It looks like the right numbers are floating around. Why is it none?
The hypotenuse shouldn't be twice the side to side because it needs to be the biggest one.
Yeah, if I'm trying to make these proportional, I notice that 7 times 2 is 14. I'm just thinking about the scale factor, right? So this side should be 12, not the hypotenuse, right? So that one is none. It actually isn't. So you can see that there are some on here that are not.